So hello and welcome. I'm Professor Sean Tavalia, Academic Chair of Physical Science at Suffolk County Community College and founding member of the board of Hamptons Observatory. For those of you not familiar with our organization, the Hamptons Observatory was founded nearly 20 years ago with a mission to promote an understanding and appreciation for sciences through free quality educational programs like this. Tonight's event is co-sponsored by Suffolk County Community College's NSF-sponsored iSuccess program, a program that provides scholarships and extracurricular activities for students enrolled in STEM fields. Although this event is free, it could not be possible without the generous donations from people like you. For more information on how you can donate to ensure these programs continue, please visit our website. If tonight's presentation inspires you to learn more, please consider enrolling in one of the many traditional or online astronomy courses offered at Suffolk County Community College. Sorry for the shameless plug. Tonight's speaker is the Frank B. Baird Jr. Professor of Science at Harvard University. He has authored nearly 1,000 scientific papers, led the first international project supported by the Strategic Defense Initiative, was a long-term member of the Institute for Advanced Study at Princeton, and is a best-selling author of 8 books, the most recent of which is entitled Interstellar, The Search for Extraterrestrial Life and Our Future in the Stars. Dr. Loeb is the head of the Galileo Project and the director for theory and computation within the Harvard-Smithsonian Center for Astrophysics. He was the longest-serving chair of Harvard's Department of Astronomy, the founding director of Harvard's Black Hole Initiative, and a former member of the President's Council of Advisors on Science and Technology. In 2012, Time magazine named Dr. Loeb as one of the 25 most influential people in space, and in 2020, Dr. Loeb was selected as one of the most inspiring Israelis of the last decade. It's an honor to have him join us tonight, so please join me in welcoming Dr. Avi Loeb. Dr. Loeb, the floor is yours.
Thank you so much, Sean, for the introduction, and it's a great pleasure to join all of you. And I will try to leave as much time as possible for your questions so that I will learn something today from you. So let me share my screen and start the presentation. This is a photo that was taken by the New York Times Magazine about a couple of years ago, and it asks the question how I became interested in the potential of searching for aliens. And I will describe details that will explain my interest in hunting for aliens. But if I had to summarize it in one sentence, I would say science is better than politics. And that is in the sense that we should be guided by evidence rather than by opinions, especially on questions that are of great interest to the public. And we should not wait for the government to tell us what lies outside the solar system. The sky is not classified. We can look up. And in fact, if we find that we have a neighbor that is smarter than our civilization in our cosmic neighborhood, that would fulfill a very important wish because we need a better role model than our politicians right now. Now, Enrico Fermi, a distinguished physicist, asked about 70 years ago, where is everybody? If there are so many stars and so many planets like the Earth around them, why don't we see anyone around us? And this is a question that is being asked by lonely people very often. And what you tell lonely people is you should be proactive. You are not that attractive that people will come to you. You need to search for your partner. And Enrico Fermi didn't build a telescope. He was just expecting extraterrestrials to appear and have lunch with him. Now, what is often said by mainstream scientists is that extraordinary claims require extraordinary evidence. But the idea that there might be something like us around other stars is not extraordinary at all, because we know that out of the hundreds of billions of stars like the sun within the Milky Way galaxy, at least a few percent have a planet the size of the Earth, roughly the same separation. So imagining something like us around those stars is not extraordinary. In fact, it's an ordinary claim. And ordinary claims require ordinary evidence. We just need to search for it rather than have an opinion. I mean, it obviously flatters our ego to imagine that there is nothing as good as we are. When my daughters were infants and they stayed at home, they thought that the world centers on them and that they are the pinnacle of creation, that there is no other infant as attention deserving as they are. And even though they started in the crib, eventually they crawled, and eventually they stood up and looked through the windows and they saw other houses, but they never imagined that there are infants that are as interesting as they are, until the first day in the kindergarten when they had a psychological shock. And we see a lot of houses in our cosmic street that look just like ours, and we refuse to accept the possibility that they have residents just like us. We regard that as an extraordinary claim. Now, life is a self-fulfilling prophecy, so it's much better to be an optimist and search, because otherwise, if you don't search, you will not find anything, and it would be a self-fulfilling prophecy not to have that evidence. And the reason I seek a higher intelligence in interstellar space is because I don't find it here on Earth. Now, new scientific knowledge does not fall into our lap. We had to invest $10 billion in the Large Hadron Collider, as well as in the Webb telescope. And after the last election, Peter Thiel appeared on a podcast and said that nobody should bet against Elon Musk. And so the following day, I placed a public bet against Elon, because he said that we should go to Mars since we are probably alone and we have a cosmic responsibility for preserving our civilization. I said, no, it's actually the other way around. Most probably, there were things like us billions of years ago. But to figure out which argument is correct, we need evidence, and I'm willing to put 1% of my net worth against 1% of Elon's net worth, which would be $4 billion for him. And then we put it in a pool and search for technological objects near Earth, perhaps space trash, that came from other civilization. And if we don't find anything, then I'm willing to give a second 1% of my net worth to him in 10 years. We're spending $2.4 trillion in military budgets worldwide just to protect ourselves from others who might be engaged in trying to kill us or to kill others. But this is just because we focus on what happens on this rock that we were born on. There is much more real estate in outer space. And if we were to invest $2.4 trillion in space exploration, we would be able to launch a CubeSat towards every star in the Milky Way galaxy within this century. It's just a question of priorities. The astronomer, speaking about priorities, decided recently to invest at least $10 billion in the next big observatory called the Habitable World Observatory that will potentially be built in the 2040s in search for microbes on exoplanets around other stars. I believe that we should hedge our bets, because microbes, as much as we would like to know whether they are everywhere, their signatures on the chemical composition of atmospheres of other planets is very subtle. And if we find, on the other hand, a technological artifact from another civilization, we would not only know that there is life elsewhere, but that it's also intelligent. And frankly, it's much more exciting to know about other neighbors that we could learn from, because they may have developed by now technologies that represent our future. Within the solar system, there is one object that I really wish to visit, and that is a moon of Saturn called Titan, because it's the only object other than Earth in the solar system that has liquid water flowing on its surface in the form of oceans, lakes, rivers, of methane and ethane, compared to Earth that has liquid water. And the reason I want to go there is to go fishing and check if there is any life in that liquid. If there is life there, it would imply that it's life as we don't know it, because we only are familiar with life in liquid water. There will be a mission by NASA called Dragonfly that is supposed to visit Titan and will be launched in 2028. Closer to Earth, the Director of National Intelligence submitted 3 reports in recent years to the US Congress, arguing that there are objects that cannot be identified. And there are 2 ways to interpret that. Either the intelligence agencies are not doing their job, and these objects belong to adversarial nations, or maybe some of them arrived at Earth from another star. There was a new office in the Pentagon called the All Domain Anomaly Resolution Office. It looked back at these reports and argued that they can explain about 97% of all reported cases. But from a scientific point of view, even if 1 in a million happens to originate from an extraterrestrial origin, that would be big news, perhaps the biggest discovery ever made in science. So while the government is preoccupied with national security, my day job is to find what lies outside the solar system. And we shouldn't ask the government to be our source of information on that matter. So about 3.5 years ago, we established the Galileo Project at Harvard University, and by now we have an operating observatory. And the observatory includes various instruments in the optical band, in the infrared band, in the radio band, and in audio that are monitoring the sky at all times. And you can see one of them that looks like half a sphere, like R2-D2, in the middle of this illustration. It includes 8 cameras that operate in the infrared, look at the entire sky. And the data is being processed by machine learning software. And the AI algorithms are trying to figure out if the objects we see are familiar, whether they are drones, balloons, airplanes, satellites, birds, or something else. And we are currently going through about 100,000 objects every month detected by this observatory. We published a paper on the first 500,000 objects that we analyzed. And obviously, if we see anything that is dramatically different from what we expect from human-made technologies, we would write a paper just on that object and share the data with the public. And we just recently received funding over the past 2 months or so for 3 additional observatories. one in Pennsylvania, another one in Nevada, and the third one in Indiana. The last one in Indiana will be associated with a STEM education center. And that I find very important to educate the next generation of scientists that will not have a prejudice and will seek evidence as a way of learning something new. Over the past decade, there was a new frontier in astronomy, and it involves interstellar objects, objects that originated from outside the solar system. And the way we identify such objects is by the fact that they're moving faster than the speed needed to escape from the gravitational pull of the sun. The first one was spotted on January 8th, 2014, more than a decade ago. And it was a meteor, roughly half a meter in size, that collided with Earth and was spotted by US government satellites that detected the fireball that was generated as a result of its friction on air. And about 3.5 years later, there was an object discovered by a telescope in Hawaii that was given the name Oumuamua, which means a scout in the Hawaiian language. This one was about 100 meters in size, bigger than our biggest rocket, Starship. And it was unusual because it was most likely flat in its shape, and it was pushed away from the sun by some mysterious force without showing cometary evaporation. The interstellar meteor was also unusual because it exploded only in the lower atmosphere, where the stress on it was much larger than the stress that all other meteors in the NASA catalog were able to sustain. And finally, in 2019, there was an object that looked just like a familiar comet. And that one obviously was natural in origin, but the first two were anomalous. And I was asked, why doesn't the last one convince me that Oumuamua, for example, was natural in origin? And I said, well, if you go down the street and you see a weird person, and after that you see a normal person, meeting the normal person doesn't make the weird person normal. So it's an object by object that one needs to make a decision as to how unusual it is. And so Oumuamua was unusual in the sense that its brightness was changing by a factor of 10 as it was tumbling every 8 hours. And it was most likely, at the 91% confidence, flat based on the variation of light from it, not cigar-shaped, as some people suspected. When projected on the sky, it had it looked like a cigar because that's the way that if you imagine a piece of paper tumbling in the wind, when you look at it sideways, it looks elongated. And then it had an excess push away from the sun with no cometary evaporation, no sign of any rocket effect acting on it. And so the question was, what is pushing it? And I suggested that maybe it's a reflection of sunlight. But comet experts argued that Oumuamua has a tail, but it's invisible. And I just maintain the view that this emperor has no clothes because we don't see the clothes. But we have limited data on Oumuamua, and therefore the question of what was its nature, whether it was an empty trash bag from another civilization or a very unusual rock, remains unresolved. Could have been also a broken piece of a megastructure, like a Dyson sphere. We know of space trash that we produced. And in fact, on January 2nd this year, the organization responsible for identifying new asteroids, the Minor Planet Center, announced a new asteroid near Earth. And then within 17 hours after the announcement, astronomers realized actually the orbital parameters of this object, this asteroid, match the orbital parameters of the Tesla Roadster car that was launched by SpaceX as a dummy payload on the Falcon Heavy in 2018. So it's not an asteroid. And then in December 2024, astronomers argued that there is a new population of dark comets. And in a paper that we posted just a week ago, we argued with my postdoc that actually one of the objects may be a Soviet spacecraft, Venera 2, that was launched in 1965, because this particular object came close to Earth just at the time of the launch, and then came close to Venus just at the time that this spacecraft was supposed to reach Venus. And then the radio communication with this spacecraft was lost, and nobody noticed it afterwards. And so it's possible that this dark comet is just a spacecraft. And in fact, this actually happened also on September 17, 2020, when the same telescope in Hawaii that discovered Oumuamua discovered another object 3 years later that was given the name 2020 SO. And then they realized that it was pushed by reflecting sunlight, and it's actually the upper stage of a lunar lander that was launched in 1966. There are many more examples of such confusions between rocks of a type that we've never seen before and technological debris that we launched. But if we allow that for all these objects that are near Earth or not necessarily near Earth, like the Tesla Roadster car, why wouldn't we allow it for Oumuamua? And for the same reason that koalas are not classified as monkeys without a visible tail, we should not classify spacecraft as dark comets without a visible tail. Calling something a dark comet is an oxymoron, because comets are recognized by their tail. So if we don't see a tail, and yet we also notice that the object has some additional force acting on it, it may be technological in origin. But when we call it a dark comet, we are introducing a prejudice about the nature of the object. And my point is that the next Copernican revolution might be that we are not at the intellectual center of the universe. Nicolaus Copernicus argued that we're not at the center of the solar system, of the world. The Earth is not there, and perhaps the sun is at the center of the solar system. And I was actually invited a year ago to give a talk celebrating 550 years to the birth of Nicolaus Copernicus in his birth town, Torun in Poland. And I called it the next Copernican revolution. And as it turns out, there are about 1 million objects that are roughly the size of a person within the orbit of the Earth around the sun that originated from outside the solar system based on the statistics of the meteor that we found. And that means that we can search for the keys under the lamppost, because the sun illuminates the darkness of space. And if we build a dedicated telescope, I showed in a paper from a couple of weeks ago, we could actually find these objects from interstellar space and look whether there is any space trash among the rocks that came into the solar system from outside. Now, the reason we should allow that possibility is because most stars form billions of years before the sun. The sun just formed in the last 1/3 of cosmic history. And Voyager, the spacecraft, will be on the opposite side of the Milky Way galaxy relative to the sun in 1 billion years. So there was plenty of time for other civilizations to reach us by now, to have their probes enter the solar system from the other side of the Milky Way galaxy. We haven't done any extensive search for objects that may be of technological origin in the inner region of the solar system. And that is why a couple of years ago, I decided to lead an expedition to the Pacific Ocean to search for the materials of the first recognized interstellar meteor that was identified by US government satellites. So in fact, there was an official letter to NASA from the US Space Command after we pointed out the existence of this meteor. And that letter confirmed that the original data from the US satellites implies that this object was indeed interstellar at the 99.999% confidence. And they provided also the light curve of the fireball, and it showed 3 flares separated by 0.2 of a second. And they implied that the object had unusual material strength because it exploded only in the lower atmosphere. It was tougher than all documented meteorites in the NASA catalog, hundreds of them. And it also had an unusual speed. It was faster than 95% of the stars in the vicinity of the sun. And so the question was, could it be an extraterrestrial car? Maybe Elon Musk is not the most accomplished space entrepreneur since the Big Bang, 13.8 billion years ago. And so I led an expedition. This is the team that went with me on the deck of the ship that was called Silver Star. As we went on this expedition to the location that was identified by the US government as the fireball site. And we used a magnetic sled, a sled covered with magnets on both sides that we placed on the ocean floor about a mile deep. And we went back and forth across a region of 7 miles around the location that was identified as the fireball site by the US government. And there was also a Netflix documentary filming crew that came with us, and that documentary will show up on Netflix within a year. You can see some photos of that, of them filming me as I was jogging every morning at sunrise, as I do often on land. And the director asked me at the end of that run, that was actually 3 times longer than usual, an hour and a half. He asked me, Avi, it looks like you're running. Are you running away from something or towards something? And I said both. I'm running away from some of my colleagues who have very strong opinions and are not seeking evidence to support them. And I'm running towards a higher intelligence in interstellar space. And so what we did is collect the materials from the ocean floor, and these are magnetic particles, roughly 1 millimeter in size or smaller. We brushed them off the sled that you see here, and eventually put all the material in the black suitcase that you see on the other side, that was shipped by FedEx to my office. And from there, I brought it to Stein Jacobson, my colleague at Harvard, who is a world-renowned geochemist. You see him standing on the right side of me here. And to my left is a summer intern, Sophie Bergstrom, who went through all the materials and found the vast majority of the molten droplets that we later analyzed. And here is an example of one of them. You can see how distinct these molten droplets were relative to the background sand. And we picked them with tweezers. And we found that 20% of those fragments were of an origin that does not resemble materials from the solar system. These fragments that we call differentiated had some elements with an abundance that is much more enhanced relative to solar system composition. And in particular, about half of them had a chemical composition that is different from all past reports on solar system materials. What you're looking at here is the abundance of various elements from the periodic table, with elements that are most volatile on the right-hand side of the horizontal axis. These are elements that would be lost under very extreme heat or temperature that one gets in an explosion of a meteor. And indeed, we find those elements on the right-hand side missing in those fragments. So that implies that they most likely came from a meteor event. And on the left-hand side of this diagram, we can see some elements that have abundances up to 1,000 times more than solar system composition. And these are elements like beryllium, lanthanum, and uranium. And that's why we call this chemical composition, which is unique. It doesn't resemble what you find on the crust of the Earth, the Moon, Mars, or asteroids within the solar system. We called it BeLaU for beryllium, lanthanum, and uranium. And it suggested that maybe we found some material that came from outside the solar system. But to be sure of the nature of the object, we're planning the next expedition. We don't have the funding as of yet for that one. The first one cost $1.5 million. The second one will be more expensive, and because it will attempt to find bigger pieces in the wreckage of this meteor. And what you're looking at is a picture from the last day of the expedition, when I was looking at the sunset together with the navigator of the ship, Art Wright, and we were planning the next expedition. And we have already a ship that we identified called Nautilus that has a remotely operated vehicle. That's a robot that we hope to put on the ocean floor and collect bigger pieces of the original object. And to do that, we will have a video feed that allows us to see what we are picking up, as long as we have the funding to pay for the ship. And so the ship will become available to us in August this year if we get the funding for the down payment for the ship, which will be more than $1 million. So if you know of anyone that might be interested in joining us on this expedition, let me know if they can pay for it. And this upcoming year, 2025, will be very exciting because there would be also a telescope that was funded by the National Science Foundation, starting its operations in Chile. It's called the Rubin Observatory, and it will survey the southern sky every 4 nights. And it would have an aperture that could detect an Oumuamua-like object every few months. And it will use a camera that has 3.2 gigapixels, about 1,000 times more pixels than your cell phone camera. So aside from detecting interstellar objects like Oumuamua, it could find also unidentified objects closer to Earth. And so altogether, the new Galileo Project Observatories, the potential for going again to the interstellar meteor site and finding bigger pieces, and the data from the Rubin Observatory will likely make 2025 a very exciting year for us. Thank you so much, and I'll be glad to answer any questions.
Thank you, Dr. Loeb. That you changed my mind. I'm a geologist and obviously an amateur astronomer, and I remember when all of this was going on and thinking, why couldn't it be just something from our solar system? And then putting my geologist hat back on and, thinking it's flat. And how do I explain that? And I can't. Uh, so this talk worked.
Well,
That
I'm just advocating that we should get more data. The biggest pleasure I will get is if we, out of curiosity, will get much more data on the next member of Oumuamua's family,
Mhm.
because it will become clear what the nature of the object is, and there wouldn't be as much room for our imagination. And that's the way we learn, by collecting data. And the worst thing you can do is argue, oh, it's a rock of a type that we've never seen before, problem solved, let's move on and forget about it. That's the worst you can do.
Yeah. So we had a few questions in the chat. Some of them I'll just read because they might need a little further clarification. The first from Katz is he's very curious regarding the studies done at Robert Moses State Park and Cedar Beach on Long Island, and says that he's a ham radio operator, and your work fascinates me and somewhat like something I wanted to do several years ago involving multi-static SDR-based radar, and just interested in what are some of the things that you have found and any explanations for unusual phenomena. There's a lot there.
We haven't yet identified an object that would be very puzzling so far. And part of the reason is that we haven't done triangulation. So the hope is that with the new observatories, we'll have multiple units looking at the same object from different directions so that we can infer the distance. Once we know the distance, it would allow us to figure out the speed of the object and the acceleration of the object, which would make it very easy to tell whether it's human-made or not. And so we are really waiting to this summer, once we have triangulation data, so that we can figure out how unusual the objects are. And the radio data that we collect is completely passive. We are not using a radar. We are not transmitting anything. We are just looking at the reflection of radio waves from radio stations or TV stations of objects in the sky.
Just a follow-up from myself, is it possible that we just don't know enough about our own solar system?
Oh, definitely. Are, uh, there are potentially objects of great interest within the solar system, but you can separate those from interstellar objects by their speed, because in order for them to be bound to the sun, these objects must be moving less than the escape speed from the sun at their location. And so, of course, there could be objects that were trapped in the solar system that came from interstellar space. Those are more difficult to differentiate from solar system objects, but the ones that are interstellar are easy to separate because they move very fast.
Donna wants to know, well, states that Oumuamua will be returning this year. Will that provide the Galileo Project an opportunity to investigate it further?
It will not be returning because it's not bound to the sun. So Oumuamua is simply on its way out from the solar system. In fact, the interesting fact about Oumuamua was that it was nearly at rest in the frame of the Milky Way galaxy near the sun. So the sun is, just like any other star, has some speed relative to the local reference frame of the Milky Way galaxy, which is defined by taking the average of the nearby stars. And it's just like going to a center of a city. You see cars zooming by, and if you average over the speeds or the velocity of all the cars, you end up in the frame of the city center. And so the local frame of reference which is called the local standard of rest of the Milky Way galaxy, is such that all the stars, I mean, are moving relative to it, and we get to it by averaging the motions of all the stars. And was surprising about Oumuamua is that it was nearly at rest in that frame. And so that implies that it didn't come from any of the nearby stars that are zooming by. It was somehow, for some reason, it was almost stationary in that special frame of reference. And then the sun, the solar system, just bumped into it. And that was a surprise that it was much slower in that frame than most stars.
Barbara would like to know whereabouts was the sled being dragged on the Pacific?
So that was about 50 miles away from Papua New Guinea, outside the territorial waters of Papua New Guinea. Um, the closest island was Manus Island. That's where our ship left towards the site of the fireball.
So a few years back, I was researching the enigmatic Carolina Bays, as the geologist often goes down a certain rabbit hole. And microspherules are a big part of some of the original studies there. And I was wondering, from a standpoint of looking for microspherules, I remember a paper of citizen science where they were asking people to take samples from their gutters.
Yes.
Have you thought about doing that for a citizen
Yeah,
science?
the only problem is that most of the material that we collect on Earth came from the solar system. You know, um, the fraction of the material that is interstellar in origin is of the order of a tenth of a percent. And so when you need to look at 1,000 meteorites before you would find one that came from interstellar space. And how would we know if we weren't around to measure the speed of the object? We won't know. So that's why it's important to go to sites of interstellar meteors where we had some information about their speed before they collided with Earth, so that we know they're interstellar. And then we found some special fingerprints that identify
Mhm.
such meteors. And then we go, in principle, we can go to meteorite collections and look for those chemical fingerprints that make them unusual.
Roger has a great question. Kind of goes back to a little Carl Sagan too. If Darwin is correct and survival of the fittest is a galactic norm, um, it may not be good for us to find a superior. What are your
Oh
thoughts?
no, I think okay. So if we imagine like any class that has students of different from different levels, we probably represent sort of the median of the population of technological civilizations. And if you were to imagine that many of them are inferior to us, to find them would require a lot of work, because we would need to board a spacecraft, reach their planet, and start searching through the jungles there if they're not very sophisticated. That's a lot of work. And on the other hand, if you apply Darwin's principle to interstellar travel, those that are most accomplished, the fittest, are the ones that will get to our backyard and will inspire us. And frankly, I don't think we pose a threat to them, because they are so much superior, so much more superior. And moreover, they um, they 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 do not care about us. You know, we have a problem that we keep thinking that it's all about us, that we are at the center of the universe, that even if we are not at the physical center of the universe, we are probably the pinnacle of creation, that there is nothing better than us. We keep thinking that even if they exist, they would visit us because of us. But you know, if they arrive at our backyard, they left on their journey possibly 1 billion years ago. We were not around back then. We just came to exist in the last, I mean, the human species came to exist in the last few million years, and we developed our technologies in the last 100 years. And so, that's just the end of their journey. They didn't have us in mind. And frankly, we are probably inferior to them. I don't think they care about us much. That may explain why they don't approach us and communicate with us directly. And so I don't think that we should worry about them doing something to us, because we are, as far as they are concerned, we are indistinguishable from nature for throughout most of our history.
Thank you. So our next two questions are related. Barbara wants to know, why are scientists skeptical that 1M1 IM1 is interstellar? And Michael has a longer similar question that says, how do current biases or assumptions in scientific communities limit our understanding or discovery of extraterrestrial life? What should we be looking for instead to broaden our search beyond conventional expectations? And how can scientists shift perspectives to more effectively identify genuine signs of intelligent extraterrestrial civilizations?
Okay, so there are many aspects to those questions. So let me start from a historic anecdote that before 1803, it was believed that rocks cannot fall from the sky. We find rocks on Earth, and then there was a meteor shower in Liège, France, that convinced the public, after witnessing 3,000 pieces. It became obvious that indeed rocks can fall from the sky. And now, 220 years later, the scientists who focus on the study of rocks falling from the sky insist that only rocks can appear in the sky, and they must be from the solar system. So when the US government reported the data, and then the US Space Command confirmed the data that this meteor was of interstellar origin, my colleagues, those that work on solar system asteroids, insisted that they don't believe the US government. They said the US government makes mistakes. We don't believe their data. It was not obtained by astronomers. But there is a lot of data that is obtained, for example, by amateur astronomers, like the discovery of supernovae, discovery of meteors. That's never an issue. But on this one, just because the velocity data indicated an interstellar origin, there was a huge amount of pushback saying simply, we don't believe the data. And there was nothing that I could do to convince those people other than reach out to the US Space Command through the White House. And that resulted in a letter to NASA that the US Space Command sent, in which they said that they looked back at the data and they confirmed at the 99.999% the conclusion that it's interstellar in origin. And even after that letter was sent, they said, the astronomers said, we don't believe that letter. We don't believe the data. And when there is data that the US Space Command looks back at and confirms, I cannot do more than that. The US government discovered, for example, gamma ray bursts. These are flashes in gamma rays back in the early 1970s, and that ushered a new era in astronomy, where eventually it was realized that gamma ray bursts originate from the edge of the universe. Now, back then, nobody said we don't believe the US government. But on this one, they insisted. And so that was the first argument that was made. And then when we went on the expedition, they said, you will not find anything. Okay, so when we came back with materials, they said, and by the way, it was always the same group of people that initiated those papers. The same group of people argued, oh, what you found is probably coal ash. And then we checked 60 elements from the periodic table and demonstrated it's not coal ash. So then the argument was, the meteor was actually a truck. Now, why would they say that? After all, the fireball released 1% of the Hiroshima atomic bomb energy, and the truck will not produce so much energy. So we relied on the localization associated with the fireball. But In addition to that, we looked at some data that came from a seismometer nearby. And so a group of people said, oh, this seismometer data could be just as a result of a truck that passed nearby. Therefore, you went to the wrong place and this was misguided. And I tried to explain that, in fact, we selected the search area based on the fireball data from the light that was emitted and was detected by US government satellites. That was the region that we went to. It was not related to the seismometer, but it didn't. They said, no, you went to the wrong place. So basically, this group of people tried to argue in any possible way that this should not be attended to, this data. And other than collect materials and analyze them for a year, and now we have two publications in peer-reviewed journals, I don't know what else to do about that, because if someone says I don't believe the data, then and they, by the way, they have no access to the actual materials, so there is nothing else I can do as a scientist other than collect more data.
So do you think this is similar to, I want to relate it back to Galileo, it's a good
Well,
example, and Harry Hess, right? When we look at plate tectonics and a heliocentric, does it require us to maybe get scientists out of the scientific head and just allow them to think and use a story?
yeah, I think it's not just the pushback against the data. Like someone can say, I don't believe the data. It's the fact that they have a problem with me doing the scientific work of
Yeah,
collecting materials, analyzing the materials. I'm doing all the heavy lifting, going to the Pacific Ocean. Instead of them saying, oh, that's interesting. Okay, we don't believe this or that, but instead, they are attacking me for actually doing the work. And the damage of that is that young people who are trying to innovate see that. And obviously, what they conclude from that is not to innovate,
right.
because never deviate from the beaten path. Because if you want to get a job in the field, you should not try to do something different. And I think that is the biggest damage to the way
Yeah.
science is done, because I am not vulnerable to their attacks. I established myself, but the young people are, and so it goes beyond the specific research that I'm doing. And
Mm.
I think that common sense should not be controversial. When I say let's allow for a possibility, they should not say this is ridiculous, this should not be pursued. Okay? It should be all based on evidence. And because otherwise, if we don't collect the evidence, we will never realize that there is something we missed.
Yeah.
Um, and with respect to um, the future, obviously, I hope that we will have a flood of data, as much data as possible, so that this scrutiny will not hold water. They will, just like in the case of Hess or Galileo. And there was an artist, a sculptor, the most accomplished sculptor in the US, called Greg Wyatt, who decided to make a sculpture of Galileo, and he donated it to my office a month ago. And it's made of bronze, and we had a celebration of that. So artists are definitely inspired by the kind of work that I'm doing. And I will just keep doing it, because I think that's the approach that science should take. And I think that all these people who are arguing we don't believe data and we don't want you to do that, and this is ridiculous, they are basically anti-science, because they are not following the scientific method. They have a very strong view and trying to find all possible reasons to dismiss an idea based on their prejudice. And remind me of the other aspects of the question, so I can
You
address.
you you covered it all. You got
Oh,
everything
okay.
right.
Okay.
And just Barbara followed that up with who are they? They're scientists, and at the end of it, they're also people. So we have to get through that bias, and it is difficult. And I'm thinking as you're talking, it's after how many years of constantly being proven that we're wrong about our own assumptions, you would think we can move past it.
Well, it goes beyond that, because For example, the mainstream in theoretical physics right now is string theory, and that has no evidence to support the existence of extra dimensions. Even
Mm,
supersymmetry, which was assumed to be the foundation of string theory, was not found in the Large Hadron Collider. So you
mm,
have a community of theoretical physicists, and they regard themselves as the mainstream, which has no evidence whatsoever to the underlying assumptions that they make. And that is regarded fine. That is perfectly fine because there is a big enough community who believes in that. So it's not, Richard Feynman said about 50 years ago, he said that it doesn't really matter how smart you are, how respected you are, who you are. If you if your assumption is proven wrong by experiment, it's wrong. Okay. And so the key here is that Feynman belonged to the generation of physicists that believe that you should test your ideas. However, the mainstream of theoretical physics right now forgot about what Feynman said. They don't need experimental evidence. They can continue for 50 years to do whatever they are doing. And why is that accepted as completely legitimate? They're using it as a sandbox to demonstrate that they are smart. That's all, that they can do mathematical gymnastics. So you find this situation as well. And then another idea, which is completely in the mainstream of astronomy right now, is the search for dark matter. We for the last 5 decades, we invested billions of dollars in searching for specific types of dark matter. We haven't found it. So I'm saying let's invest similar level of funding, billions of dollars, in the search for technological objects from other civilizations within the solar system. And if we don't find anything, let's say in 50 years, we would be exactly at the same point as the search for dark matter is right now. So, I mean, if you ask the public, what would they like to know the answer to, the nature of dark matter or whether we are alone? Obviously, most taxpayers will say, are we alone?
mm,
And we should invest similar funding in that question. But academia divorced itself from the public interest. And that is, I think, inappropriate.
mm. Thank you for that. Uh, Donna wants to know, is this attitude that we're dealing with, is it global or is it more in some parts of the world than others?
No, I think people, I mean, now with the internet and communication, uh, there is very strong, and social media in particular, there is a very strong regression to the mean. That's the way I describe it, where uh, the mainstream view dominates the conversation because you, if you are seeking funding or you're seeking promotion in your professional status, you have to dance to the tunes of promotion committees or funding committees that are populated by people who wish to amplify their voice in the echo chambers that exist. So you have to play by the dogma in order to get funded, in order to get promoted, in order to get recognized, get honors and awards and so forth. And that is global. It's not restricted to a particular country or a particular field. Um, and you can see the effect of that because a century ago, there was an avalanche of discoveries. And right now, discoveries are rare. So we have to invest billions of dollars. And even then, we don't make a major breakthrough in the context of the Large Hadron Collider, except for verifying that the Higgs boson exists. This was predicted in the 1960s. And the biggest advances are done in the context of artificial intelligence, information technology, not in the context of physics right now.
Mm. So change the direction. Jim wants to know if you're familiar with the research done by on micrometeorites by John Larson,
There
and
are
if
many people working on micrometeorites, and as I said before, they are all associated with materials from the solar system.
so. I had a question that I wrote down when you were talking about that. Some of the strange compositions. Is there any way of checking that against some of the compositions of near star systems, or?
Yeah, so that would be one thing. And the other one is that we are working on right now is trying to find the isotopes that will tell us the age of the material. And that would also indicate what kind of origin it had.
Eric wants to know if there's a way for citizen science to contribute to your project, the Galileo project.
Yeah, so in fact, one of the future observatories will display the data publicly so that if a member of the public will notice an object before our AI system does it, we would credit that person, and that person could be part of the paper that we write about it if the object turns out to be very unusual. And also, one of the observatories will be in a STEM education center where I very much hope to engage students, young adults in the analysis process. I will need to go in a couple of minutes.
Yep, and we are all set. The last statement here was by Roger, and I think I can sum it up on our conclusion and way out. Roger says, tell them where the data is so they can see it and make an informed decision. And I think part of the problem that Dr. Loeb is talking about is the bias doesn't let them want to see the data. And that's the struggle that we all have in a lot of ways. And it's trying, that funding aspect is really, it does. I agree with you, Dr. Loeb. It
Well,
stifles innovation.
let me give an example that I realized recently. There is a whole population of objects that behave in strange ways near Earth, and they are called empty trash bag objects. I was not aware of them until a month ago. And still, you hear SETI scientists arguing there is no credible evidence for anomalous objects. Why? Because anything that moves in a way that is a little complicated, the zigzag way, or is classified as an empty trash bag that is perhaps pushed by reflecting sunlight. And so it's being shoved under the carpet, so we don't need to think about it. And obviously, there is no credible evidence for anomalous objects because those that are anomalous are not being discussed. And in the same way that Oumuamua, even though it was anomalous, the experts on comets argue that it's a dark comet. And so, what can you say? I mean, they say there is a tail, it's invisible, it's a comet of a type that we've never seen before. And when you approach science this way, that everything can be explained as a dark comet or as an empty trash bag object, obviously there is no credible evidence for anything else.
Thank you, Dr. Loeb. I really appreciate this. This was a wonderful talk. I really appreciate you taking the time and sharing your views. Thank you for doing your work. Thank you for doing everything you can to take the time and study the things that others will not. I appreciate everything you're doing, and thank you. Thank you for joining us.
Thanks for hosting me. It was a great pleasure to address the questions that you had.
Have a wonderful night.
Thank you. Bye bye.